Hi everyone, and you are welcome to this lecture, Bitwise Operators. In this lecture, we are going to learn about Bitwise Operators, in which we will see Bitwise AND, OR, XOR, NOT, left shift, right shift operators. And as usual, I'm going to end this lecture by a quick summary. So let's get started. First of all, let's start by defining what Bitwise operators are. Bitwise operators are operators that we use usually to perform bitwise calculations on integer numbers after we transform these numbers to the binary system, in which the numbers are represented by zeros and ones only. Now let's see all of these operators' details. For all of them except NOT, all of these operators take two operands, and these operands should be numbers, especially integer, and we transform this integer to binary before doing any calculation. And once we execute any one of these operators, the result is also a number, and it's an integer number. For the case of NOT, number of operands is 1, the operand data type should be an integer, and also after we apply this operator, the result is gonna be integer also. It's highly probable that most of you are not familiar before with these operators, so I'm going to explain these operators in details. Let's start talking about AND or XOR. I have an example. Let me assume that I have A equal to 17, B equal to 19, and I want to calculate A and B. Since these operators are bitwise operators, first of all, I'm going to convert A and B into binary system, and this is what I will get. I want to calculate AND, so I will put AND operator between them, and then I will start doing the calculation. Since it's bitwise operator, this means I'm going to apply AND operator in each two neighboring bits. So 1 and 1 is 1, 0 and 1 is 0, 0 and 0 is 0, 0 and 0 is 0, 1 and 1 is 1. As you see here, the result now it's in the binary system. I will convert this result back to the integer that we are already familiar with, and I will get 17. So 17 and 19 equal to 17. Now, if you want to calculate OR or XOR, we are going to do the same thing, except that we have to apply the operator OR or XOR. How OR and or XOR operators work is provided in the appendix, so please refer to if you are not familiar with before. Now let's talk about NOT. Assume I have also A equal to 17, and I want to calculate NOT A. How I am going to do that? First of all, I will convert A into binary system, which is 1, 0, 0, 0, 1. Then I will start to do the calculation. As we know that NOT invert the bit value. So if I have 1, I will get 0. If I have 0, I will get 1. So NOT 1 is 0, NOT 0 is 1, 1, 1, and 0. Now I will convert back the result into integer, so it's very straightforward. Now let's talk about left shift. Also, assume I have A equal to 17 and I want to calculate A left shift 2. And 2 here mean number of shift bits. First of all, let me imagine that it's not an integer, it's a float, which is 17.0. If I want to write this number in binary system, I will write something like this. So the first part in the left is 17 and the second part, which is on the right, is 0. Now let's calculate A left shift 2. In left shift, you have to imagine that we will take two zeros or 2 bits from right and we will shift them to the left, as you see here. And then I will put the same number exactly without any change. In this case, you can see that we have now 2 new bits on the right, and the result in this case is 68. So we can conclude that in left shift, we gain some bits and especially 0 bits on the right. Now let's talk about bitwise operators right shift. Again, I will assume that I have A equal to 17 and I want now to calculate A right shift 2, and in this case 2 also is the number of shift bits. To calculate this, first of all, I have to convert A into binary system, then I am going to do the calculation. You can imagine in right shift that we are going to throw some bits from the number. So, because I want to do right shift for 2 bits, so you can imagine that I will lose or I will throw these 2 bits from the number, and I will take the remaining bits exactly without any change. And as you see, this is my result. I will convert the result back to the integer value and I will get 4 as you see here. So we can conclude that in right shift, we lose some bits. So that's all about how these operators work. Now let's move to PyCharm IDE in order to see some real examples about these operators. In the previous slides, I have explained exactly how each one of these operators work. Now let me show you the syntax of these operators. First of all, I will assume that A equal to 17, P equal to 19, and I am using the same numbers that I have used in the slides to get the same result exactly. Now, to use Bitwise AND operator, you have to use AND symbol. For the case of Bitwise OR operator, you have to use bar symbol. For XOR case, you will use hat. For NOT, you are going to use this tilde, and for left shift, you are going to use two arrows directing to the left, and for right shift, you will use two arrows directing to the right. Also, you will see that for all of these operators, I'm using two operands. So for example, here AB, and so on, except for NOT, in which we use one operand only. Now, let me run and see the result that I will get. So A and B is 17, A or B is 19, A X or B is 2, not B is minus 20, A left shift 2 is 68, and A right shift 2 is 4. And that's all for this code session. Now let's summarize what we have learned in this lecture. First of all, bitwise operators have been defined, and as we see, these operators are used to perform bitwise calculations on integer numbers after we transform these numbers to the binary system. We see that for all of the operators except of NOT, we have two operands, and these two operands should be integer, and the final result after we do the calculation is also an integer. For the case of NOT, we have only one operand, and also it should be an integer, and the result after we execute NOT is also another integer. Please refer to the file Bitwise Operators Appendix, in which you will find all of these operators have been summarized. Also refer to the file Bitwise Operators Challenges, in which you will find some exercises to practice what you have learned. Thank you very much for your time, and if you are available, join me in the next lecture.